So today we are going to expand our knowledge of building function by including other types of variations. So there are different types of variations, and we are going to explore all those types of variations now. Okay? Does that make sense? So that takes us to the topic, which is build functions, and we are focusing on variations. So we have introduced variation, and we are going to expand to different types of variations. So I want to list those types of variations, then we'll start taking them one after the other. So you can say that subtopic is types of variation. Now on the types of variation, we have number one on the list is direct variation. Number two on the list is inverse variation. Number three on the list is combined variation. And number four is joint variation. So these are different types of variations. So, and we have introduced the first one. So on this first one, in today's class, I will only give you just a little bit different layer of it. It is still a varied direction, but slightly different from the one you saw last class. Okay? So now, for the direct variation, we can do this. For the direct variations, we can say that a quantity y varies directly as x. So in other words, a quantity y varies directly as x. You can also say that y is directly proportional to x. You can say that y is directly proportional to x. It's the same statement. It means the same thing. It means exactly the same thing. So you can say y varies directly as x, or y is directly proportional to x. Okay? So now let's represent it in mathematical symbol. In mathematical symbol, we can say that y is directly proportional to x. That means y is equal to kx. If we remove the sign of the proportionality, so y is equal to kx. Okay? An example, a classical example of this, a physical example of this would be that circumference of a circle is equal to 2 pi r. Circumference of a circle is one quantity, radius is another quantity. 2 and pi are constant of proportionality, and they are both numbers. So we might as well write this formula as 3.14 multiplied by 2 will be 8 to 6. We might as well write this formula as 6.28 radius equal to circumference. Okay? Okay. On the other hand, sometimes the direct variation produces a number that is that has a power, that has an exponent. Direct variation produces a function that has an exponent. So in that case, it is called direct variation as nth power. So let's consider direct variation as an nth power. Okay. So now, in this type of situation, you can have that y varies directly as the power as square of x. Y varies directly as square of x, or even cube of x, or even fourth power of x, or even fifth power of x. Okay, so now if we have to write it using mathematical symbol, that would be that y varies as x squared. In that case, that means it follows that y is equal to kx squared. Okay. Now a classical physical quantity that can be represented by this variation as an nth power would be area of a circle. Area is pi r squared. See, we started using area and circumference too many years ago in either Math 8 or Math 7 or even Math 6. Okay. So now let's give an example. Let's give an example. We can say, here's an example. So let's give an example of this second one. We can say that the area of a circle varies directly as the square of the radius. So let's write it down. The area of a circle varies directly as the square of its radius. One circle, or you can say a circle. Let me write that with a different, this is now an example. Example, let me just say example. Example, a circle has an area of 32 centimeters squared and radius of let's say 5 centimeters. The question is what is the area of the circle? What is the area of the circle if the radius is 9 centimeters? Okay, so this is a classical question. It doesn't have to be based on a circle. It can be based on any other two quantities, So I just chose circle because there's already a formula. There's already a formula that looks like that. There's already a formula that looks like this. That's the only reason why I chose a circle. Okay, so now let's try to find a solution to this type of a problem. Can somebody read it? Somebody just read what I wrote. I need a volunteer. Quickly read this. Yeah, please go.
Can you read from the red or the black?
Yeah, the one on the black, please.
Okay. A circle has an area of 32 centimeters square and a radius of 5 centimeters. What is the area of the circle if the radius is 9 centimeters?
Okay, already you know that. Already, somebody else read the one on red, please. Read the one on red. Another person.
The area of a circle varies directly as the square of its radius.
Exactly. So this is where we are starting. This is where we are starting from here. That's where you are starting from. That's where you create your mathematical equation. You see? So now we are moving above somebody giving us an equation. Now we are moving into creating the equation by ourselves. You know, in previous classes, we are just working on other people's formula. Now we are going into the mode where we create the formula ourselves. And that is actually the real world. All these apps that you use, that's how they were developed. Somebody created the formula or the algorithm by themselves. Okay, so now in this particular case, let me use that to provide a solution. So here's what you do. You have to deal with this first. You will say that area is directly proportional to square of radius. That's where you start. And it implies that area is equal to K R squared. Forget about this time around, you are now forgetting about this pi. You are forgetting about the pi because we are trying to determine what that pi is. Okay? So this is our formula. And then they gave us that a circle has an area of 32 centimeters squared. So the area is 32. And then K multiplied by radius is what? Radius is 5. You have 5 squared. Okay? So then that would be 32 equal to K multiplied by 5 squared is what? 5 squared is what?
25.
25 multiplied by 25. So in order for us to get K, what do we do?
Divide 25 on both sides.
Divide both sides by 25. Divide both sides by 25. So what you're doing is you divide them by 25 and you divide them by 25, and that will eliminate this. So you have your K to be 32 divided by 25. So K is equal to 32 over 25. If you like, you can put it in decimal. All right. Now, but let's not waste the time. Now, let's now find the area of the circle if the radius is 9 centimeters. If the radius is 9 centimeters. So now we have found K. So now let's now find the area of the circle. So the area of the circle now would be area is equal to, then we go back to this formula. We just say 32 over 25 multiplied by the radius is 9. So we write 9 squared. That's when we need to use our calculator to punch in the number. So let me share a calculator quickly. You can use your cell phone calculator at this point.
81.
What?
81. This is 9 times 9.
Okay, 9 times 9 is 81. So you can just write 32 times 81 divided by 25. So use your calculator to give me the answer. You can use
103.68.
103.68. Okay, area now is 103.68 centimeters squared. So that's how to get it. Meanwhile, in terms of fraction, what is 32 divided by 25? Just do 32 divided by 25.
1.28.
What? 1 point what?
28.
Okay, 28. Okay. So as far as this problem is concerned, our pi is 1.28. Our pi is not 3.12 as far as this problem is concerned. Am I making sense? Sense?
Yes.
All right, thank you.
Yeah.
So this is how to, like I said before, it doesn't really have to be area. It can be any other two quantities. And it doesn't have to be square. It can be cube here. It can be fourth power. It can be fifth power. So this is how it's called direct variation as nth power. This is how it works. This is how it is done.